Welcome to the introduction of Spring. So in this particular module, we'll be talking about what exactly Spring Framework is, what are the various modules which constitutes Spring, what are the various components of Spring Framework, the inversion of control, also called as dependency injection. We'll be looking at how a typical object lifecycle looks inside Spring or the Bean lifecycle. We will look into the application context. Application context is primarily the global name using which you can communicate with Spring container. You can query beans, you can look at the life cycle, you can destroy, you can initialize, you can define aspects. A lot of things can be done using application context. So we'll learn about that. The next topic is going to be around Spring configuration. So how do you configure your Spring for bean creation, bean initialization, bean destroy, and on top of it, all the framework which is very much encompassed within Spring. How do you configure them, right? Say for example, if you want to configure transaction, how do you configure transaction? What is the data source, the database username, password, and all other details that will primarily be coming into Spring configuration. There is an additional way of configuring a Spring, that is through XML. Install STS 4.0, installing Lombok plugin in STS 4.0, STS tool 3 plugin. Injecting objects through setters and constructors. So in XML, using property tag, you would be able to inject an object into another object. So that is setter based, and similarly you can do constructor based as well. The other thing which you'll be learning is that you can inject for other data type as well. For example, for map also you can inject through XML. For collection also you can inject through XML. Inner bean concept. So essentially the bean scope would be very much within a bean, right? And the moment the outer bean creation is done, inner bean will not be available for anybody, including you programmer, to use, right? So we'll be learning about inner bean. We'll also see how to create an alias. So one bean can be accessed through multiple names. So we'll look into that as well, primarily in a demo. We'll look at life cycle of a bean. Life cycle means right from creation of the object to initialization of the bean, using the bean, and then destroy. And finally, we'll be learning about the scope of the bean, to be very precise. These are the agenda we'll try to uncover in this particular section of this module. So let's go them one by one. Now let's understand what the framework itself is, right? So a Spring framework, as I already said, it's a lightweight solution, and using which you can write many multiple and reusable enterprise level application, right? It is not recommended for embedded system, but yes, surely for enterprise application, for B2B application, for B2C application, it is very well recommended, very widely used. It provides a very simple and rich facility to integrate various framework. I have been quoting this framework of framework, right? So it abstracts many framework within it. So if you want to harness a struts feature, use Spring. If you want to harness Hibernate, Spring. Log4j, Spring. JSF, Spring. To name a few. Various databases, say for example SQL, Spring, Cassandra, Spring, MongoDB, Spring. So it gives you a very clear abstraction over multiple technologies, right? And once you are familiar with Spring, you would know that it's not that difficult to learn other technologies as well. So that is why it is called framework of framework. Now, if we talk about some of the benefits, surely it is very minimally invasive, right? So you don't need to write too much of code. With a minimally invasive code, you can actually start developing your features. It is loosely coupled, right? So the components within Springs are loosely coupled because it follows dependency injection and also follows a typical interface based approach while you are using some of its feature. Declarative programming is used in abundance in Spring, right? And just to quote an example, at the method label, if you write at the rate transaction, all the instructions within the method would be by default, would be following ACID properties, would be transactional in nature. We will be talking about ACID in one of the classes, so don't worry about it if you don't follow it. Now, and lot of boilerplate reduction would be done because it has some feature called aspect and templates, right? And we'll be talking about aspect and template in the upcoming class as well. If I talk about the feature and modules, so primarily 9 features and modules which we'll be touch basing throughout. Of course, the number one would be inversion of control or dependency injection, where the control of creation of object is taken by whom? By Spring. Aspect oriented programming. So programmer only deal with aspect. Programmer only deal with transaction, only deal with logging. security, monitoring. You are not going into detail of these aspects, right? So how to do aspect-oriented programming, we'll be learning about that. If you want to integrate your application with some data access, how can you do that? So we will be going through that as well. And while building a web application, the feature called MVC will be navigating that piece as well. That also constitutes in the Spring framework. RMI is nothing but is remote access invocation. So if one JVM wish to talk to other JVM in the same data center, across region, how can it invoke the remote API? So Spring also has abstraction for these kind of features. To name few more, remote management, right? So you can also do some hardware management using, which will not be going into detail in our classes. Messaging, so you can use JMS for messaging. Messaging is asynchronous passing of message or events from one process to another process, right? So that's messaging, very integral part of Spring framework. And testing, Spring has lot of support for test. Lot of the test libraries are by default included in Spring. So we'll be going through some of the test strategy as the class progresses. Last but not the least feature which we'll be exploring in our class is authentication and authorization. So how to secure your APIs, because most of the time your APIs would be out in the public. How do you secure it? How do you provide right authorization to the user? We'll be talking about that as well. Move into our Spring framework architecture. So primarily, unless you are an open source developer, you won't be going and contributing to a Spring framework, but it's always good to know how the Spring is built up. To be very precise, if you look at this diagram, it talks about 5 different aspects, 5 different components or building block of Spring framework. The number one being the data access or integration layer, where some of the features like JDBC, ORM, OXM, JMS transaction are part of. The other is web, where you can do web development using Spring framework. The next is AOP, which is aspect oriented programming, aspects and instrumentation. And the third, rather the fourth, would be the core container itself. So Spring has its own runtime. So the own runtime is what we call as a container. And last but not the least is the test support for the Spring, right? So these are the 5 different components which builds the Spring framework as a whole. Let's go into them one by one. So let's go into data access and integration, and let's see what are the features this particular layer provides to you. So JDBC is nothing but Java database component using which you can talk to any database. So this particular feature comes from JDBC. The other 4 would be ORM, object relationship mapping. So it supports Hibernate. So internally it uses Hibernate, gives a very good abstraction over Hibernate. So that is called ORM. It also gives a very good mapping for XML binding. So your data model with your Java code can be converted into XML, and XML can be converted into Java node. So Java Pojo rather. So both this to and fro transformation of data model is very much possible in Spring. The next being the JMS, which is essentially you can send messages from one JVM to other JVM. That is Java Messaging Service. Support for that is again given here. And transaction. So transaction is nothing but is, in a very simple term, the literal meaning is do all or none. So if you have say 4 instruction inside a method, you'd want all the 4 in the same order to be executed or none of them to be executed. Why that so? So that your data is not inconsistent if there is a partial failure. Suppose step number 3 is failing again and again, right? Your framework is not letting only 1 and 2 pass and 3 and 4 fail, right? Because of which you are pretty much at a consistent state. So transaction support both the declarative and rather programmatic, right? Both the support is given by Spring framework, and we'll be learning in our hands-on as well. So let's deep dive into web. If I talk about web in the upcoming classes, we'll be going deeper into the web. We will see how the IOC works and how some of the feature of web can be harnessed to build web APIs, right? The next is aspect and test. An aspect is what? So in an application, there is some concern which is cross-cutting concern. Cross-cutting means they are agnostic about businesses. Say for example, logging. If you are logging some log in production, it has to do nothing with business. If you are securing an API, it has to do nothing with business, right? If you are doing transaction management, nothing to do with business, right? So all these cross-cutting concerns are called aspect. So we'll be looking into some of the aspect oriented programming, and this component primarily aspect and test layer talks about AOP, aspect oriented programming. There are certain notions which you'll be learning as the class progresses. One of them is aspect, the other is point cut and similar terms. But for now, understand that this is one component which builds your Spring framework. There is a rich support for instrumentation in Spring, and we'll be talking about that as well. And testing, as I said, a lot of testing libraries are encompassed within a Spring for you to use it readily, right? You don't need to look at version, which version is compatible with this Spring version, and so on, so forth. All you need to do is import the Spring, and all the test libraries will be there for you to use. So the third is aspects and test layer. The core layer is the, you can say, the runtime of Spring. One of the component is the core, where all the dependency injection and IOC inversion of control. And if I say dependency injection, it simply means that, take an example, suppose class A uses class B, right? It needs class B and it is willing to invoke B dot method M1. Class A need to have handle of B. How would class A get the handle of B? Through dependency injection. That means somebody has to provide instance of B to class A, right? Who would do that? Spring will do that. And inversion of control is both class A and B. Creation of object in a Spring term, it is called as bean, would be done by Spring, not by developers. So this particular feature is part of core component of Spring framework. And as I said, the object is primarily known as bean in Spring. So bean is another component. Special expression, you might or you might not use this feature of Spring in abundance, but a special expression is primarily about evaluating some runtime expression at runtime. So we'll be learning about special expression as well. Context is, again, think this as a global context using which application programmer can talk to a Spring container. You can query a bean, you can fire expression queries, you can kill a bean, you can reinstantiate a bean. Lot of things can be done using application context. You can load the context from XML, you can load the context from annotation. So a lot of these programmatic features can be done by the component context, Spring context. Spring container, the real runtime container of Spring. So if you look at this diagram, it simply says that you provide a XML to Spring, and Spring will create Spring bean for you. It will create object for you, and whenever you need the object, you just query this bean factory. You'll get the object, you use the object and return it back to the bean factory. Not all the objects will be returned back. There are objects which are singleton. There are objects whose life cycle can be very limited. So there are varieties of bean which you can create, and those beans will be created using bean factory. So as I said, what container does, it initializes the bean. Before initialization, it creates the object. And you know how object creation happens in Java. If you're creating an object of, say, person, so it will be like person p equals to new person. This is the instruction which is given to your JVM. JVM will create an object for person, and then what Spring does is Spring initializes the person, right? So there might be some init method. Init will be called. Some properties will be populated, right? Some of the properties you would be injecting from property file, right? So those property would be populated, and then the application context for that bean would be initialized. Remember, what is application context? Application context is a global entity using which you will be talking to a Spring container. So that application context will be injected in that bean, and then init method will be called. The first lifecycle method init will be called, and then the bean is ready for use. So don't get confused, right? Bean has multiple steps, right from object creation, which is the job of JVM, to all these four steps, which is instantiate bean, populate properties, set bean factory in it, and then the actual uses of the bean. It could be a method M1, M2, any custom method which you would want to use. And then when the application is going down or container is going down, just before that, destroy method will be called. So this is a typical life cycle of a bean. For a Spring developer, it is very much needed that you know the life cycle of the bean. Bean is not object. Object is not bean. Bean is object plus plus. What are those plus? These are those plus plus steps. If we talk about application context, it's a global entity using which you will be talking to application. you'll be talking to container more than framework, right? And there are two ways using which you can talk to application. One is class path XML, which means the XML is in your class path, and there you are adding all the configurations. Spring reads those configuration, initializes the bean, destroys when the application is going to shut down. The other similar ways, though the way is different, but the life cycle would be very much similar to as we have learned just now. The other way is annotation based. So in annotation based, what you do, you define annotation. Annotation is what? Over class, you define at the rate. Over method, you define at the rate. Over field, you define at the rate and some instruction, right? Those are annotations. So you can also tell Spring, you can also configure Spring using these simple annotation. And both way you can initialize your application context. Now, as I was telling you, the configuration can be XML or can be annotation, as we will look into both these ways in the upcoming demos. So let's go on. Let's open the browser and search for Spring STS4. Go to Spring STS4. It's not very difficult to spot. Scroll down a bit and look at Linux 64-bit. So this is a zip file which will be downloaded on your machine, and once downloaded, it will be, you can keep it anywhere. I have kept it inside this folder which is in my home. So I've kept it inside Spring Workspace, and this is here. All you need to do is right click and extract here. And once you extract, there will be a folder inside which all the Eclipse or STS binary will be placed. All you need to remember is this is the cell file which will launch the Spring. Additionally, if you look at it carefully, I've also created a folder for all my code base. So this is the location where all my code base will be kept. You can do it now, or while setting up your project, you can do from STS as well. I have also created a shortcut of the script file which will launch my STS, this file. So you can say right click and send to desktop, create shortcut. Yeah. So we'll launch through shortcut. Let's launch the STS 4.0. And when it is coming for the very first time, it will locate you some default location. Don't go there, or you may choose that as well. But as I was telling you, I have created a sandbox folder inside Spring Workspace. So choose that location and say launch. Once you launch it, it will give you a variety of options to create either a Java project or a Spring Starter project or a simple Spring project or any other project as well. But because this tool is primarily customized for Spring development, hence Spring Starter and getting started with Spring, these two options are coming as a major option. So now that the IDE is launched, we would need to install a couple of more plugins. Number one plugin would be for Spring itself, because this is a later version, this is 4.0. We are going to pull some plugins from STS 3.0 using which you can create Spring XML files, right? And some other features as well. So go to Eclipse Marketplace and search for Spring tool. So Spring tool, type here Spring tool, say enter. And because I have already installed it, so the option which I'm seeing here is installed. Look at this. Spring Tool 3 is already installed. If you're doing it for the very first time, say install and it will be installed. It will ask you to restart it, and the current state which you are seeing here on my desktop will be seen to you. So you need this plugin for sure, right? Install this plugin for sure. You can install other plugins as well, but let's not talk about that. If you want to install any plugin, this is the place for you. Go to Help and Eclipse Marketplace and search for the plugin and install. You can look at all the installed here, the default installed here. Now it has all the plugin which is required for me to do the Spring development. I'll show you how to create your very first project. These are the two options which you can use to run any, or rather build any kind of Spring project. We'll be using Spring Starter project for creating Spring projects as well. So click on create new Spring Starter, and here you say my first project. And this is something which we'll be doing for all the demos, right? So don't worry about it. Once you do it yourself, next time onwards, it would be very repetitive. Type would be Gradle. So we'll be using Gradle 3.x. Java version, the default 8. You can also choose other version as well if you want. Let's keep it 8. And here give com Edureka.spring. You can give any other group, and usually this group and this package would be same. So keep this way, keep com.edureka.spring, com.edureka.spring, and say next. Search for web. Rather, any starter project will work. If you want to run any Spring code, any starter will work, but we are choosing web. So choose web here. This will be shown here, and choose Lombok. Remember, we have installed Lombok. I'll tell you what Lombok is in a while, but choose Lombok here. Only these two for now. As the class progresses, we'll be choosing more options. Say next and say finish. The project is building 36% and going on. So open your first project and you would see all the folders are by default created. There would be a single file name as my first project application. Open that and you will see that as a Spring Boot application. We are not going to use Spring Boot feature. We'll be using Spring demos in this project. In later classes, I will also tell you that how you can build without Spring Boot dependency, but that's something for later. And if you go to build.gradle, the two dependencies which we have chosen is here, right? So we have chosen web and we have chosen Lombok, right? And I'll tell you what Lombok is in a while, but these are the two dependency which we are going to use in our application. Now to ascertain that my setup is all good, say right click and run as Spring Boot app. So this has failed. Look at it, right? It is saying that port number 8080 is already in use. So we will be changing the default port from port number 8080 to some other port. Say go to your SRC main resources and application properties and say server.port equals to 8081 and go to your application and run it. First save it and go to your first application and right click run as Spring Boot app. Now look at this, it has started at 8081. So your setup is all good, and by default we are using web, so you will see Apache Tomcat, all these containers coming up. Don't worry about it, we are not going to use the Apache Tomcat for now. This is just a project setup which I'm trying to ascertain before we deep dive into hands-on. Close this, we don't need this for now. You would have noticed that I've used Lombok. So what is Lombok? So create a model, create a Pojo, say new class, and I'm going to create a class name as say spring.model, and inside model I'm going to say person, finish. This is my person class. Now you know what would be the generic person attribute, say name of the person, say age of the person, and so on and so forth, right? Now if you were to create getter and setter, the very simple option is you provide, or rather you write all the getter and setter yourself, right? So public static void set public string get and all that. You can also do that using id feature. So right click, refactor, and you can say rather source, and you can say create getter and setter, create hash code equal to string constructor from superclass. So all these options you can do in the ID itself. What Lombok is going to do for you is that you simply say add the rate data. Now this data is nothing but is coming from where? Lombok. So annotate this with data, and the moment you annotate, write a main method to see if the getter and setter is available for you to use. So static void main string varargs and say person equals to new person and person dot set. So look at this, right? Now set age. There is no method we have written explicitly, but it is available for me to use, right? Set age person dot set name, and not only this, you can also say get person dot get name, person dot get age. So the boilerplate of getter and setter will be reduced to much extent, right? Not only getter setter, you can also do equals and hash code, right? So equals and hash code, so that will be generated here. You can also use builder design pattern. You can create objects using builder. If you don't know what is builder, just go and read about builder design pattern from Gang of Four. So the builder will be available for you to create any object. You can say no R constructor. You can say all R constructor. So all these features are available for you to use, right? And you don't need to write code for this. Why it is giving me error? Yeah, constructor. All are not constructors, constructor, right? So now you know what is the benefit of Lombok. And remember, for Lombok, to use Lombok, we have used, or rather, we have downloaded the Lombok plugin. We have installed in Eclipse in STS 4.0 for us to use in later classes. Demo, we are going to look into how DI works, right? Dependency injection works in Spring. So let's start creating a Spring starter project. And in the earlier demo, I have already showcased you how you can create a project. So let's say it's a first module. So let's say it is, the name of the module is Introduction of Spring, and say next. And we have used these two already, so choose Lombok and web, say next, and say finish. So in this demo, as I said, we'll be looking into how you can do dependency injection, DI. So that means, take an example, you have a class A and you have a class B, and class A contains class B. Class A knows about class B. How would you, or rather how would you tell Spring to have B available for A in class A? So in class A can do something like b.m1 or b.m2. So at runtime, how would A be accessing B? So for that, let's create the class A, and let's take a more concrete example. Let's say the class name is employee. So you're going to say, let's give a name, say it's demo1, and here you are going to, let's name it as dependency injection, and here you are going to say create class A, and let's take a concrete name, employee. Now employee is created, and needless to say, whenever you are creating an object, don't forget to give a data annotation here, data annotation Lombok. Now the employee must be having some name, string name, and integer age. And let's create another class, new class, and this time the class name would be, say, company. Now you know the relationship between company and employee. Don't forget to give a Lombok annotation here as well. So you have data already here, and company has employees, right? So let's say employ, employee, employee. Now the problem statement is, at runtime, how would company get the handle of employee instance? That's the problem statement, right? So to solve that, what we are going to do is, we'll be creating a XML. We'll be creating a application context XML or a Spring configuration file. So let's do that. New, and say other, and here search for Spring Bean configuration file. Say next. Give the name as application context dot xml. Say next. And by default, a lot of these will come up. We are primarily interested in Bean for now because we are going to create Bean. So let's use Bean for now, and not much anything, right? And in Bean, choose the most latest one. So choose Spring Bean 4.3.xst version. Say next and finish. So by default, you will see a Bean file getting generated, a XML file getting generated. And here you need to tell Spring what your Bean is going to be, right? And what is my first Bean? Employee. So say Bean, and here say ID. Give a ID to your Bean, a unique identifier. Say employee, and say class. So class is nothing but is employee. Now there is no body, so you can prefer to choose it here itself, close here itself. And your second one is what? Second one is company. So say Bean ID equals to company, class equals to company. You need to give the full qualified name, give company. Now company has employees. Remember, company has employees. So how I can inject employee within company? Remember, we have setters in company, right? So all I'm going to say here is that property name, and what is the property name? Employee, and then say a reference, pass the reference as this employee, this ID, right? So that means the XML will inject, yeah, so XML will inject what? This particular bean inside company. We have two more properties here in employee, right? Name and age. So you can define, rather you can populate those things here as well, right? So let's define those things here. You can say property name equals to age and value equals to, see, everything will go as a string. Even though the data type is integer, Spring will by default convert or automatically convert those string value into integer. We have a second property as well, say property and say name. We have already given age, name equals to Edureka, value equals to Edureka. Alright, so this bean configuration looks fine to me. This is looking fine to me. So just do a proper indentation. Now the question is, how do I test it? So to test it, we will be writing some test. And to write some test, you need to do this. Go to your test folder and write a test here. Say right click, new class, and say this is your introduction of Spring test. And because all the required jar for the test is already there, simply import test org JUnit Jupyter API and write a test. Give a name something like public void should di using setter. Alright, now to test it, just right click and say run as JUnit test. So before writing the test, I want to make sure that my setup is all good. So it says some error. So the jar for JUnit is not there in the class path. Run as Gradle test. It should be fine. It is fine. It is working perfectly fine. So it has run perfectly fine. And so you can see here the test which has run. Should di using setter. It is all green, right? The test is all green. Yes, look at this, right? So the test is all green. Now we can write the test comfortably. So remember we talked about application context. So pick application context, not org app Catalina, rather Spring Framework application context. Say application context equals to new class path XML application context and give the file name. What is the file name? So the file name is application context. I'll minimize this so that I get more space for my window. So application context.xml, and once this is done, I can query my bean from this application context. How would I query it? I'll say application context dot get bean, and here you can give the bean name. What is my bean name? What I want to query? You can query either company or the person, but primarily I'm curious about company and within company the person. So let's query company and also give the class type. So company dot class, and what in turn you will get is a company. And now guys, remember, first of all, check if my company is not null, right? So I'm going to use assertions dot assert that company is not null. Okay, and my second assertion is going to be assertions dot assert that my company dot get employee is not null. If this happens, that means my injection has worked. Yes or no? It has worked, right? So run this, right click, run as. You can also use shortcuts, but let's run using Gradle build. Yep, it has passed, all green. So that proves a simple dependency injection. You can also do dependency injection using constructor. So for constructor, I probably will not do it using constructor, but I'll surely show you how you can do it. So rather than here, what you can say is rather than you injecting through property employee, you can inject something like constructor args and then ref equals to employee, right? It will be having the same effect as your setter base employee. So it will be having the same effect as your setter based dependency injection. It is giving error because there is no constructor which takes employee within company, right? So to fix that, what you need to do is go here and say all arg constructor. And once you do that, come back here. Now the issue is gone. So similarly, all you need to do here is that because we are doing using constructor, this should again pass. So this is the beauty of test, guys, right? You write it once and run it many times as you want, as long as the feature is not breaking. So all green. So this was constructor. So I hope dependency injection is clear, folks. So in the next one, I'll be taking you through some more bean scope, the typical bean life cycle. When you initialize a bean, the life cycle of the bean, how it goes from init until destroy, right? So that will be taken through bean interfaces and a scope. Inner bean, I have already created an XML where there is a bean definition for country, and this is country, and one of the property of country is state. If you want to look into that, let's go inside. So one of the property of country is state, and here I am not defining the state outside this bean. It is in fact inside the bean. So property name state, and look at this, right? So inside property bean ID state, and then this bean definition is very much similar to any other bean definition. Only difference is it is getting injected from inside, right? Bean ID state and property name Edureka. Now the second concept which we did talk about is the alias. So if you want to access this country bean, the other way would be through alias, right? So you can say context.getBean, and in place of ID give the alias, right? Country alias. You would be having the same bean, same object. The third thing which is worth, look at this. This is a lifecycle bean where there are essentially two methods. One is init, other is destroyed. I have defined two variables, initialized and destroyed, where if init is called, initialized is true, and if destroy is called, destroyed is true. And this is again would be ornamented with data so that you can read initialized and destroy. Here I'm loading the demo2 and I'm loading the country. Remember, this country should not only be null, the state inside this country also should be not null. So let's run this and see the behavior. So this is passed. You would want to verify state as well, just to make sure that state again is not null. So say country.getState also should be not null. Similarly, you can query by alias. I'll leave it to you to verify the alias and life cycle as well, right? Let's write a test to verify the bean init and destroy. So what we can do is we can copy this test because most of the initialization are going to be similar. Should initialize, should call init and destroy. So demo2, and here the bean is going to change. So the bean is going to be lifecycle bean. So I'll be calling lifecycle bean. Let's use demo2 because that is where we have made the changes, and lifecycle bean and lifecycle bean. I am hoping that I have given the same name there, and simply change this to L is not null, and most importantly I want to verify is init call, right? So I would highly recommend you to put a SOP and see, because the implementation which we have done, destroy you won't be able to verify because bean container will be shut down just before the JVM shutdown. So you won't be able to see the destroy, but let's see if we are able to see for init. Is initialized true, and let's say, so let's run this. So the test passed, right? So this verifies the init, and again, as I requested, you try it out destroy by putting SOP, and that should again work fine. Thank you very much.